Bismillah ar-Rahman ar-Rahim. Last time we discussed Boolean algebra identities and properties, and also the duality principle. Okay. We discussed these properties. Okay. And then in the lecture that I recorded offline, I explained two examples, okay, using algebraic manipulation to simplify Boolean functions. We proved the simplification rule, which is this rule here. And also, I proved the consensus theorem, okay? So today, if you want to see how we did that, go back to lecture 7.2, and it is explained there. If you have questions, ask me after you watch the video, please, okay? All right, today we are going to continue by giving more examples, okay? So we have this function here. I have this function, which is this expression, okay? And we would like to simplify f using algebraic manipulations to the minimum number of literals. Okay? A literal, when we say a literal, we mean a letter that is either complemented or true, okay? So the number of literals in the original expression is how many? We have a complement, which is 1, B is 2, C complement 3, 4, 5, 6, 7, 8. Notice that I'm double counting a complement, okay? It's fine. We count the total number of letters, including repetition, okay? 9, 10, okay? So we have 10 literals in this expression. We would like to use algebraic manipulations to try to simplify this and minimize the number of literals, and we will justify our steps as we go in the process. Okay, so all I have done here is to rewrite the expression so that when I scroll down, you don't have to look up here. Okay. All right. So this is the original expression. Let me just pull it up a little bit. All right. This is the original expression, and this you can say, well, by using the distributive law, we can, okay, take B as a common factor between these two expressions. Okay, if you take B here, you get the remaining expression is going to be A complement ANDed with C complement ORed with D complement C. And the remaining expression here is going to be A ORed with A complement DC. Okay, let me write that. So I can say B. And then for the first sub-expression, it's going to be A complement, C complement, ORed with D complement, C, okay? And then the second part is going to be this expression without the parentheses because it's preceded by an OR, okay? So we can say A or A complement DC, right? Is that right? Okay. This is by, so I would like to justify my step. So this is using the distributive law, okay? Remember the distributive law, it says x, xy, or xz is equal to x as a common factor y or z, right? This is what we used, okay? Next, what can we do here? what law can we use in order to further simplify the expression? Now you see that the number of literals has reduced to by one. I'm sorry, it has reduced by one. Let's count the number of literals. The original expression has 10 literals. Now this expression has how many literals? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are one less literals than the original expression. Now I want to use the Boolean algebra tricks to further simplify my expression. Who can suggest a way to do that?
Sorry, to do what?
To further simplify the expression.
Can't take the C common, maybe?
What do you mean? This one here?
Yes?
In this expression here, this is C complement and this is C. Can you take them as common?
Oh, I thought both of them were C.
No, not both of them, but there is something else that you can do. If you go back to the rules here, there is something that we can use. Okay, no, look at this simplification rule. What does it say? X ordered with x complement y is equal to x or y. This is one less literal than the right hand side is one less literal than the left hand side. You see that? So which literal did we get rid of? The one that is ended with something else. Okay, so we have x ORed with x complement y is equal to x or y. If in the other, on the other hand, if we have x complement ORed with xy, then we get rid of the x, so we get x complement or y. Okay, so in the expression here, we have C complement ORed with C D complement, right? So which one do we get rid of?
C.
C, excellent. This C goes away. All right. So B, a complement, okay? C complement or D complement, yeah? Now this is ORed with A, and this is ORed with A complement. Actually, I can reapply this rule here, right? So I can take more than one step at a time, right? Because using the simplification rule, I can simplify. So in order to annotate my use of the rule, I can use the simplification between this and this, and this, and this, and this, and this. Do you see that? But let's do them baby steps, okay? Let's not jump into a real quick way of doing things, okay? So let's say that we didn't see that. DC, okay? This is using what we said?
Simplification.
Simplification, right? Simplification rule, okay? Is it simplification? Yeah, simplification. Let's just double check, okay? It's simplification rule, yeah. All right, so what's next? We apply the simplification again to this with this and this with this, right? So we can notice that the A, we can, by using the idempotence law, we can or the whole thing with A again. Okay, so I can say, well, here, this is equal to B, and then there is an A ORed with a complement, C complement, or D complement, ORed with, again, A ORed with a complement, DC, right? This is by what? Put it here. idempotence. Okay, I just replicated the A here. Okay, I replicated the A twice instead of just once because I want to use simplification rule here as well as here. Okay, I don't have to do this, but just for illustration, I'm doing it for illustration. Okay, so now this is equal to what? B, A, and then
A.
we get rid of the A
Yes.
complement, right?
A complement. Yes.
So now, do I need the parentheses now? The brackets for C complement or D complement? Answer is no, because it's preceded by an OR and succeeded by an OR. Okay? So there is no need for the parentheses. Okay? All right, so it's C complement or with D complement. Okay? Or A,
A. Get rid of A complement.
let me put it this way, CD, okay? So we got rid of the A complement, okay? Now, let me just copy this to the next page. Okay, copy, and then paste, okay? So this is what we reached so far, okay? So what is the justification here? What do I say for justification?
Simplification.
Simplification, yeah? And then what do I say? Well, by
Can
Morgan's
get rid of
law,
C. Oh.
I can say what? B into, oh, somebody has an idea, I think.
Yes. You can get rid of C here with CD.
Excellent. So you'd like to propose an idea to use the simplification rule again, okay?
Yes.
Okay, yeah, let's do that. Okay, fine. So A or C complement or D complement or A. Of course, I can get rid of this A now, okay? Because of idempotence, you know? And then you can say D. Both are fine, C or D, whatever you want, right? So this is by idempotence plus simplification, yeah? So who can tell me what rule tells us what is D complement or D?
It's equal to 1.
It's called, they are equal to 1, and the rule is called, or the property is called the complement property, okay? So this is equal to B, A or C complement, or with 1, right? This is by the complement property, okay? And then this is equal to B. By what? Who can tell me by what? By the null property, okay? Because null property says X ORed with 1 is 1, right? And also by and identities. What does the and identity say? It says X and with 1 is equal to X, which is in our case, X is B, okay? Any question? So this big expression turned out to be just one literal eventually. This whole expression here is equal to, in fact, B. And to convince yourself about this, you can draw the truth table or derive the truth table of this function, okay, and compare its value to B, the B column. You notice that it equals to B, okay? All right, any question? Okay, so notice that I think maybe my method here is different from the method that the other section have, okay, as well as my notes. So you have 3 different methods now to compare, okay, and to pick from. And this is a feature of Boolean algebra. There is no unique way of simplifying functions, okay? Let's see another example. So, by the way, this was an exam question. Okay, this is an exam question. Okay, appeared in one of the exams, and this one, also this one, are exam questions. Okay, so let's do this one here. So we would like to simplify this function, which is g is equal to ab complement ORed with b complement c ORed with abc complement ORed with ab. So we would like to simplify to the minimum number of letters. How many letters does the function have? Who can tell me?
9.
9. Excellent. Okay, so we will try to simplify that using or reduce that number of letters using Boolean algebra. Okay, so this is nothing but the rewriting of the function here. All right, so what can you say? What can we do? Come on, guys, ideas.
We can get rid of C complement.
C complement, this one?
Yeah, because we have C, B complement C, ORed with.
So you're saying that B complement C ORed with A, B, C complement. This turns into what?
B complement C.
Okay. ORed with?
Plus ORed with AB.
AB. Who agrees to this? Who approves this?
Shouldn't it be AB instead of B complement C?
Oh, so we have.
Who approves this? Okay, let me ask your colleagues here. Who approves that this is correct using what we learned so far? It's important to the best way to learn is from your mistakes. Okay, this is by the way, this is wrong. Okay, this is wrong, and the reason for that, you're probably confused because we know that C ORed with C complement is 1. Okay, however, if this is multiplied by something, then this relationship no longer holds. Okay, it's something else. Okay, this is something else. So even though you have C and C complement, it doesn't mean that this will get rid of the C. Okay, all right. So these 2 terms here, they don't have anything in common that you can use to simplify G. Okay, they actually, the B is complemented here and it's true here. The A is not appearing here and appearing here. The C is complemented here but not here. Do you see that? It's important that you understand that what you suggested is not correct, and it is perfectly fine to make mistakes. Okay, and this is the way how you learn, and this is the way that how I can correct your way of thinking. Okay, and I appreciate your courage to suggest this, but this is not correct. Okay, so who can tell us how can we proceed?
Isn't it better to start with taking common factors?
Okay, so what common factors you suggest?
A.
Okay. This is an excellent choice. Okay, so that the expression becomes smaller, right?
Yes.
So we take A, and then how many terms that have A? 1,
3.
2, 3, right? So we have B complement here, ORed with what? B, C complement.
B plus B.
ORed with B. And the only term that doesn't have A is B complement C. And what you did is called by the distributive law. Okay? This is, by the way, this in the exam, guys, this is required. You have to write it. Otherwise, you'll lose points. Okay? You have to tell me how you jumped from here to here. Okay? Using the distributive law here. Okay? And then, what's next? What can you suggest?
B plus B complement equals 1. I mean, B and B complement equals 1.
Excellent. So B complement ORed with B, although they are not next to each other, okay, here, but I can, using commutativity, I can switch between these two, and then they're next to each other. So this is going to be A ended with 1 or BC complement, right? ORed with B complement C, right? And this is using what? It's called the complement law, okay, or property. All right. Now, these, what can I say about this one here?
Null. This is
One,
ORed
excellent.
with-
So it is A ORed with B complement C. I mean, it's one, of course, but then by AND identity, it just disappears. So what do we call this property here?
a null.
Null,
complement.
excellent. And identity, okay? All right. So this expression has been reduced from 10 literals. Is it 10 or 9? 9
Nine.
literals. 9 literals to 3 literals. Okay. So this is the minimum it can get. Okay. By the way, there are other ways of doing this. Okay. If we have time, I will discuss that with you after we do this problem here. Okay, so this problem here, it asks you to find and simplify the complement of this function here. Given this function here, we would like to find and simplify the complement of this function. So in the previous section, what I did was to simplify the function first, because there is no restriction on which one I start with. Okay, I can simplify and find, or find and simplify the complement. Okay, but if there is, for example, find then simplify, then you have to do to find the complement first and then simplify it. Okay, so what I'm going to do now is to find the complement and then simplify it. Okay, just like the notes in your in the class notes. Okay, so my F complement is going to be equal to a big bracket here, which has the small brackets of the function. Okay, ORed with C, and then ended with D complement, ORed with A, C complement, and then close the big bracket and then have a complement here. Do you see? So this is nothing but this whole expression inside of these two brackets, and then I complemented that because I want the complement of F. Okay, now we are going to use De Morgan's law recursively. Okay, so now I have X, okay, ORed with Y complement. What does this turn into? It turns into X complement ended with Y complement by De Morgan's law, right? So, and then I get rid of the bracket, right? So I have this whole thing here, which is, can just copy this. Yeah, I need to complement this. Yeah, and then this or here turn into and then I need to complement the A and then the C complement. Yeah. Yeah. Everybody is following?
Yeah.
Okay. Now again, so this is by what? De Morgan.
De Morgan.
Okay. Again, you'll use De Morgan's so many times until things stabilize. Okay. So this one here, you have something ended with something. So it will become the complement of that something ORed with the complement of the other thing, right? So we have, we need the complement of this. Okay. Okay, the complement of this, but it has to be ORed with the complement of the complement, which is what?
D.
D. And then I need a bracket. Why? I need to surround this by a bracket because of the precedence of the and here, okay? Precedence of the and I have an or of two expressions here. So this needs to be surrounded by a bracket. Yeah? And then I have this one here, which is simple. AC complemented becomes a complement ORed with C, right? By De Morgan's. Okay? I can say here De Morgan's. All right. Now I apply De Morgan's on this one here. Okay, let me just copy this. Yeah. Actually, I don't need to copy anything. This is equal to, so the original expression is something ORed with something else complemented. So this will turn into an and, right?
Yes.
So I start with the complement of the complement of AB complemented. Okay, so I just the two complements will cancel each other and I'll get a B complement, right? Isn't it?
Yeah.
And
Yes.
then this or will become an and this C will become a C complement.
Complement.
Right? I don't need brackets here because of the same precedence here. Okay? But the outside bracket is also not required because the and does have a higher priority, higher precedence than the or. Okay? So I actually do not need the bracket here. Okay? But I still need the bracket here. Okay? This is a complement ORed with C. Okay? So this is the last, let me just copy this over to the next page so that we have space. Copy. And I think I do have an empty page. Yeah, okay. Okay, so what can I do here?
Distributive law.
Let me say here again, De Morgan's, right? I forgot my Morgan's law. Okay, so using this, so again, it's just copy of that, so I don't have to write the justification here. So using the distributive law now, I can distribute the expression here. So I have, for example, if this is my, let's say, whole thing is x here, okay? So I will multiply the x into this and then into this, and or the two things. Okay, so I have my let me make it simpler, okay, and choose my x to be this one here, instead. Okay. So this will become what? A, B complement, C complement, ORed with D, right? Into A complement, ORed with A, B complement, C complement, ORed with D into C, right? This is using distributive law. All right. Now apply distributive law again. So if you multiply this by this, what do you get?
It will cancel.
0, right? It's
Yes.
the, what we call it? What did we call the property here? The null property, right? So all you can get from this is A complement B, all right? Or with what? And again, this times this is going to be 0. So you get C,
D.
D, right?
CD.
This is by what? Distributive law.
Yeah.
Several things here. Distributive law plus null identity, null plus or identity. Why did we say or identity? Because we have 0 or with something is that thing, right? This is what we did, because the result of this is going to be the result of A complement times this is going to be a 0, and we need to add to or that 0 with A complement B, right? And by or identity, we know that this is nothing but A complement D. Okay. All right. Are we done? So
We can take common factor D.
excellent. Yeah. So because we are not requested to put this in a form, okay, that is standard form, okay, we can take a common factor to get rid of one of the literals, okay? So this equals to A complement or with C into D. So instead of 4 literals, it becomes 3 literals using distributive law.
Distributive law.
Okay. Any question about this? Okay, so if no questions are there, let me talk a little bit about the consensus theorem, okay? So in consensus theorem tells us that there is a term that you can add to a function given some conditions, okay, such that it doesn't change the value of the function, okay? So if your function is this one here, x times y, ORed with x complement times z, okay, then you can add yz without affecting the value of the function. Why did we say yz? Because we have here x and x complement in the other term, and then the rest of the terms you just multiply them or add them together to get the what we call the consensus term, okay? Consensus term here is yz, okay, and this is a redundant term, okay? So yz is a redundant term. You can get rid of it, or you can add it to simplify the function further, okay? Let me give you an example. Now in this problem here, we can use also the consensus theorem, okay? For example, let me ask you this. What is the consensus of what is the consensus of AB, the first term, and the last term? remember the consensus theorem says x times y, ordered with, now we have x here, we must have x complement here in the other term, z. Okay, so the consensus of these two, if I want to write it down like this, then the consensus will be equal to yz. So what is the consensus here? Let's compare. Take your time. It's okay.
A.
Who said A?
Um,
Muhammad?
yes, Muhammad.
Okay, excellent. Excellent answer, Muhammad. Why did you say A here?
Um,
So
Right.
what is your X in this case?
A.
No, your X.
Correct.
It's B, right? The literal B. B because
Yes.
it's
A.
one's true and one's complemented here. And
C.
the remaining is A, ended with A, but by idempotence, this is equal to A, right?
Yeah.
So by consensus, okay, by consensus, I can say, well, my G is equal to A B complement, okay, or with AB, okay. I just brought this to the beginning, okay. I just brought this expression here or term. I brought it to the beginning so that it becomes easier for me to. And I can add A as well, right? Why? Because it's the consensus of the two terms, okay? And then what? I have B complement C and A, B, C complement. And this is by consensus, right? Consensus. Okay? Now we use the absorption law, okay? How many times we use it? Absorption law. This with this, this with this, and this with this. And all they go away. Okay? So remember, the absorption law is what? What does it say? X ordered with xy is x, right? Why? Because you can take x as a common factor here, and you get one ordered with y, right? And that equals x. Okay, so by absorption here, this is equal to A ordered with B complement C, and this is by absorption. Okay? So do you see now the beauty of the consensus theorem? It just saved us. I think it's the same number of steps, more or less, but it's beautiful to use it. Okay. Any question? I think for some reason this section is less active than the previous section. I don't know why. Is it because we're approaching afternoon or noon?
Yes, maybe you are drained from.
You're so tired, huh?
Yeah, just a little bit. Yeah.
I hope you're following anyway, and
Yeah, we're doing so. I hope that too.
okay, no problem. As long as you do your homework, okay, by studying and also doing the exercises that I provided here, okay, right? You're fine, okay? Okay, I'm going to stop here and let me stop recording.